Hello, Dumelang, Molweni, Sanbonani, Nda. Welcome everyone to Lula Learn. My name is Gift and I will be your tutor for the rest of this lesson. We at Lula Learn are very happy to have you join us today. We hope that you enjoy this video and find its content helpful in your studies. Today, we'll be looking at grade 10 mathematics, algebra. This video will serve as an introduction to algebra, giving you guys all the basics that you need to know before we dive deeper into the topic. So I urge you to watch this video till the end before moving on to the next video. We start off first with algebraic expressions. And under algebraic expressions, we have terms. And what are terms, you might ask? Terms are parts of an expression. Let's say we have the algebraic expression 8y minus 12x plus 2. This is an algebraic expression, but separately so, 8y is a term on its own, negative 12x it's a term on its own, and 2 it's a term on its own. Next, we have like terms. Like terms are terms with the same variable or exponent. For example, 3x and 4x are like terms, and also 12y and 8y are like terms. However, 4x and 12y are not like terms. 3x and 4x are like terms, 12y and 8y are like terms, but 4x and 12y are not like terms. Based off everything we've learned so far, we will now take an example. We're given an expression 3x plus 6y minus 5x plus 4y, and we are required to simplify this expression. What we're going to do here is to simply combine the like terms, which in our case will be 3x with negative 5x and 6y with 4y. Remember, we said like terms are terms with the same variables or exponents. Let's combine our like terms. What is 3x minus negative 5 minus 5x? That is going to be negative 2x. And what is 6y plus 4y? That is going to be plus 10y. Now we move on to laws of exponents. And our first law is the product rule, and it states that a to the power of m multiplied by a to the power of n is equals to a to the power of m plus n. What this rule basically says is that when we are multiplying bases which are the same, we are going to add their exponents. Let's take an example. Let's say we have 7 to the power of 3 multiplied by 7 to the power of 2. Notice that we are multiplying here and the bases are the same. We have 7 here and we have 7 here, and we are multiplying, meaning that we are going to have 7 to the power of 3 plus 2. We add our exponents and our answer is 7 to the power of 5. Next, we have the quotient rule, and it states that a to the power of m divided by a to the power of n is equals to a to the power m minus n. What this rule says is that when we are dividing bases which are the same, we are going to subtract the exponents. Let's take an example. If we have 5 to the power of 6 divided by 5 to the power of 3, we have bases which are the same. We have 5 here, we also have 5 here, and we are dividing. Now this means that we are going to subtract our exponents. We will have 5 to the power 6 minus 3. Our answer will be 5 to the power of 3. Next is the zero exponent rule, which states that a to the power of 0 is equals to 1, where a cannot be equals to 0. What this rule says that whenever we have a base, and that base is to the power of 0, our answer will be 1, but a cannot be 0. Let us take an example on our calculator. Let's say we have 7 to the power of 0. Our answer is 1. We have 5 to the power 0. Our answer is 1. So whenever we have a base, and that base is to the power of 0, our answer will always be equals to 1. However, the base can never be 0, because if we have 0 to the power of 0, we have a math error. Lastly, we have the negative exponent rule, which states that a to the power negative n is equals to 1 over a to the power of n. Let's say we have, for an example, 6 to the power negative 2. We can rewrite this term as 1 over 6 to the power of 2. The last part of our introduction video is algebraic factorization. There are 3 ways in which we can factorize an algebraic expression, and the first one is common factor. This is when we are given an algebraic expression and we take out the common factor to factorize that expression. For example, let's take the expression 8x plus 4. Let's say we're required to factorize this expression. What we do is to take out the common factor between these two terms. What do you think the common factor is? If you said 4, then you're correct, because 4 goes 2 times into 8 and leaves nothing. It also goes once into 4 and leaves nothing. Then in our bracket we will have 2x plus 1. Next, we have difference of squares. This is when we have a to the power of 2 minus b to the power of 2, and then we factorize it by writing it as in bracket a minus b close bracket in bracket a plus b. Let's take an example. Let's say we have y squared plus 4. Now, I want you to notice that this 4, we can also rewrite it as 2 to the power of 2. So what we can then do is factorize this in a way as y minus 2 and y plus 2. Lastly, we have trinomials. Now, this is when we usually have a quadratic equation and we factorize it by finding 2 terms in which when we add those terms and multiply them, they will give us the second and third term. Let's take an example. Let's say we have the quadratic equation x squared plus 5x plus 6. Now, to factorize this, we will look for 2 terms in which when we add those terms, they will give us a 5, and when we multiply them, they will give us this positive 6. Now, those terms will be positive 2 and positive 3. Our answer will be x plus 2, x plus 3. We can also use a quadratic equation, but I will show you that later on during our lessons.